Hello, welcome back to YT Classroom. I hope you all are doing great. So, today we are looking at a topic of computer science or ICT as you might call it. That is, how do you convert binary numbers into generic numbers and vice versa. So, let's write down our topic today, how to convert binary numbers to denary and vice versa. Now, essentially, binary is a number format which is also known as a two-base number format because it just uses two digits, which are 0 and 1. So, using the combinations of 0 and 1, we try to basically represent any number that we can represent using our normal number system, which is from 0 to 9. That is what you have referred to as denary number system, binary numbers to denary and vice versa. So first thing that we're looking today is how to convert binary to denary, and then we'll look at denary to binary. Binary to denary. Now, the conversion of binary to denary is fairly a very easy process. So you just need to know a few basic things. First of all, you need to know the place value table for binary. Now, when I talk about the place value table, remember that in our normal numbers, you have the place value table that starts like units, tens, hundreds, and thousands. That goes in the powers of 10. So here in binary, since you only have two digits, it goes in the power of 2. So starting up, we have 1, then we have 1, then 2, and 4. Then you guess it, it's just doubling 8, 16, 32, 64, and 128. Now I'm going to write only till 128 since the standard binary number is basically 8 bits, where I'm referring to bit as a single binary digit. Alright, the next thing after drawing up this place value table, I wanted to write your binary number. So I'm just going to write a random binary number here. So 1 0 1 0 1 1 0 1, and that's really it. Now the final step is that those places which have 1 in them, like okay, so you don't take this one because this one does not have a 1, so don't take this, don't take this, and don't take this, and just add up the place value headings. So this is what I mean. You have 128 with a 1, so you're gonna add up 128 plus 32, 8, 4, and 1. So 128 plus 32 plus 8 plus 4 plus 1. And that totals up to 128 plus 32 plus 8 plus 4 plus 1, which gives us 173. Now, in some exam boards, you are allowed to use calculators in these types of questions just to do the basic maths here, while in others, especially the IGCSE Computer Science 0478, you aren't. So you're supposed to make this calculation manually, so you have to do it with addition. That's the only method of converting binary to denary, and it's the easiest you can use if I suppose there are any others. The next thing you want to look at is how to convert your denary numbers to binary numbers. Denary numbers to binary numbers. Now, essentially for this, there are two methods. I'm going to show you both of them, and people often, for some exam boards, you require an understanding of both of them, and I guess that's the best option because some one of the method works with some numbers essentially better than other. So let's say the method 1 that we're talking about, method 1. Now the first method is that you again drop the place value table 128, 64, 32, 16, 8, 4, 2, 1. And let's say the number I'm trying to convert is 45. Now this method does not work really good with large numbers since you have to draw up a lot of place value columns. So you have 45 here. Now what you want to do is you want to figure out which number is less than 45 and which number comes first. So you see that after less than 45 we have 32, and that's the first number since 64 is larger than 45, so we have 32. So you're going to 1 in the 32's column, and then you have to subtract 45 minus 32, which essentially gives you 13 if I'm not wrong. Yeah, 45 minus 32 is 13. Okay, then you want to figure out what is the next number that comes less than 13. Now clearly that's 8 here, so 13 minus 8. 13 minus 8, which gives you 5. Now the next number you have is 5, so you have 4 here. So 5 minus 4 is going to give you 1. Alright, and then finally you have 1. So if you write that in the 1 in the ones place value column, 1 minus 1 equals 0. So until you reach 0, and then what you want to do is you just want to put zeros in the rest of the columns. So here you have a completed 8-bit binary, which is a standard format, although the last digits, if they are zeros, especially if I'm talking about these ones, they aren't very essential to write. So even if you cancel out them, your 101101 essentially the same thing as this whole digit. But I'm writing this because it's a standard format. And also a tip to remember is that when you're given binary digits, make sure you hit them from the right, and if you're putting them in the place value table, make sure that you do it from the right, because if you do it from the left, you often miss out on where are you starting from. Alright, this is method 1. Now I'm gonna use the method 2 with the same number so that you guys can understand that it still gives the same answer. So let's look at method 2. Method 2 here. Method 2. So method 2, let's say you have 45. Now what I want you guys to do is you want to divide 45 by 2 and write the remainder, if any, on the other side. So if you have 45 divided by 2 gives you 2 times 2 is 24. 2 times 2 is 24, and basically what you have remaining is the remainder is gonna be 1. Alright, 2 times 2 is 24. Yeah, 2 times 24 in fact. 2 times 24, no, 2 times 22 is 24, 44, and remainder is 1. Alright, 2 times 22, yeah, 44, remainder 1. Now the next thing you want to do is again do this by 2, so 2 times 11, and you have no remainder as this is an even number, so you gotta write 0 here. Then you gotta divide again, so 2 times what do we refer to as 2 times 5 is 10, and remainder is again 1. You don't want to completely divide it, so you have to ensure that the answer is a whole number and not it does not include a digit with it, a point. Then 2 times 2 is 4. 2 times 2 is 4. Yeah, yes, yeah, okay. So again 2 times 2 is 4, and remainder is again 1. Then 2 times 1 is 2, and the remainder is 0. Now I gotta look at this value. I'm gonna look at this value. Do you see any differences, any similarities here? So when you take up this value starting from here and you move on like this on the above method, you get the same number essentially. So that's 1. I'm going to read from here. Yeah, 1 0 1 1 0 1, which is essentially 1 1 0 1 1 0 1, which is the same as this answer, except for the last 2 digits, last 2 zeros, which I told you they don't matter as long as you want to write them in the format, otherwise you can just ignore them. So you see that these both methods work and they give you the same answer. That's it, and I hope you've understood the concept. If you have any questions, you can post them in the comments and I'll respond to them as soon as possible. And also more IGCSE videos are coming out soon, so please subscribe so that you can get helpful videos as well as study tips. And I would also guys appreciate if you guys recommend any topics that you would like to be videos posted on, especially on computer science, maths, physics, accounting, business, English, economics, any of these subjects in IGCSE. I would love to do that and I would love to help you guys. Thank you so much. Thank you for watching.